And welcome back to the best of what's new. My name is Jack Dalio, covering all the latest developments in aviation for Flying Magazine. And joining us this hour for a fireside chat is JP Stewart, the Senior Vice President of Product Development for Electra.Aero. And we've got an exciting topic today. That would be Electra's flagship 9-passenger, ultra-short design, the EL9. JP, thank you for being here.
Jack, good to see you again. Thanks for taking the time.
Of course. And before we get into the nitty-gritty of the EL9, which Electra has described as really a category-defining aircraft, why don't you tell us a little bit about your background, JP?
Sure. I have the fortune of falling in love with aviation as a young kid. So started as a 4-year-old with standard model airplanes, model rockets, eventually got into flying sailplanes, and have had the great fortune as well to fly in 4 world championships on the U.S. team in gliders, and also along the way started flying powered airplanes, commercial multi-engine CFI, also fly aerobatics, have an extra 300, and some really integrated in aviation, love airplanes overall. Professionally, started in the UAS world with uncrewed aircraft, started working actually at Aurora Flight Sciences, where we really took that to a professional level. We built some really incredible aircraft, had the neat opportunity to lead propulsion and system tests at the time on an electric solar powered airplane, which had some really interesting use cases. And then actually clean sheet development of a vertical takeoff and landing aircraft with Porsche. So I spent the better part of 3 years working with Porsche on a clean sheet design, build, fly program. After the time at Aurora, I had the opportunity to really take a step back and think differently about how we move. And so all of the experience in electrification, in vertical takeoff and landing aircraft, and this future mobility concepts really came together very nicely as we set off to create Electra.
So like many folks in this industry, you have had a long time interest in aviation. Now you have this privilege of being part of a company that is developing one of the more cutting edge concepts in aviation at Electra. The EL9 design was unveiled late last year. I gave a little preview of the aircraft at the top of the discussion, but let's really dig into the concept now. So what are the key specifications, the features and capabilities, and then ultimately, what is this thing designed for? What are the use cases?
Yeah, those are good questions. I mean, fundamentally, the EL9 is this one-of-a-kind, ultra-short takeoff and landing airplane. And, you can fly in and out of traditional airports, but the real game changer is the ability to take this 9-passenger class airplane, something that's really designed for high utilization commercial operators, and have it take off and land in a 150-foot ground roll. I can do that in a Super Cub or a Helio Courier, but you can't do that with 9 people on board consistently day in and day out with those aircraft. And so the basic premise is to build an airplane. I said airplane, not a rotorcraft, not a tilt wing, anything like that. Just a simple airplane that can take 9 passengers, their bags, or 3,000 pounds of cargo, and go up to 1,100 nautical miles. Typical mission ranges are likely to be closer to 50 to 500 miles. But the fact that you can do those longer flights and even longer with ferry tanks is really a testament to some of the technical decisions that we made. And, traditional airplane cruise speeds, 175 knot max cruise, it is unpressurized. So it's really intended for, again, those shorter 50 to 500 mile flights. But you'll find that a lot of the real world operations of these airplanes, caravans, beavers, otters, are frankly even less than that. 75% of the flights in Cessna Caravans are under 150 nautical miles. And so we're really able to push the bounds to go further, but also fulfill an existing niche in the market.
So I think there are a lot of really interesting features that are part of this aircraft, but I want to focus in on that ultra short takeoff and landing capability. That's billed as one of the really, really key enabling features of the EL9, that ability to take off and land, like you said, with 150 feet of ground roll, and not necessarily from the runway. You had a flight last year, a test flight, where you took off from, about a soccer field sized grassy area. Can you break down for us how that ultra short capability works? What are the technologies that enable it and the design choices that you've made to enable it?
I'm glad you bring up the demo flights that we did last year. We have a 2-seat prototype, which is out there showing at full scale with a real pilot on board that the technologies at their core work. And all of it really comes back to enabling that ultra short takeoff and landing. I'll say, I think a lot of people tend to view electrification as a solution looking for a problem or greenwashing. And I'll just say, having been there from the beginning, that we actually started from a very different lens. I mean, our goal really early on, and it's a very pragmatic group. Oliver Macefield, the chief engineer of the PC-12, PC-24, John Langford, the founder and CEO of Aurora Flight Sciences, some preeminent professors, Mark Drayla, John Hansman at MIT in flight physics and aircraft operations. That triangle, we really got together and said, how do you actually change the way that people move? This 50 to 500 mile number that I use, I mean, that's a gap, right? Under 50 miles, you're probably going to drive. Over 500 miles, it makes a lot of sense to take commercial airplanes in a regional jet size. And if you're in the 50 to 500 mile range, if you're a pilot and you have access to an airplane, no problem, right? It works. You can do a lot of the airport to airport missions. But if you really take a step back and you look at the order of magnitude, actually 100 times more trips that happen 5,500 miles in cars, the real answer is most people just drive. And so if we have the ability to, on day one, start by replacing some of the existing operations, airport to airport, but over time, get into these really small spaces, close to where you are, close to where you want to go, that'll change how people move. And if you can do it without being a pilot, if you can do it by buying a ticket, maybe it's more like a bus, there's 3 or 4 flights leaving over the next hour or two. If you miss one, it's not that big of a deal. You're never going to miss a flight today, because if you do, that might be the only 1 or 2 for the whole day. So it's really just thinking about how to enable direct aviation. That's a little bit of an aside from then how do we end up at an ultra short takeoff and landing airplane. That comes down to the need to get in close. And we talk about this idea of direct aviation, going directly from where you are to where you want to go. How do you do that? You got to be able to get in close to the city. There's some really neat images that we can put up that show how big Washington Dulles, the airport, is relative to Washington, D.C. I mean, the airport is bigger than the city. And I think that's fairly counterintuitive. You don't really get a sense of scale when you're at these airports, but pretty much any of the big class Bravos and even a large number of the class Deltas, the airport is bigger than the primary city that it serves. And so you have to start to do something different. Those airports are already at capacity with big airplanes that are flying 3, 5, 7,000 miles. That's not really what we're here for, right? We're regional transportation to be able to go direct point to point. So that brings us back to, what is the technology that enables that, right? Starting from the end in mind, with the end in mind, what is the product? What's the solution the problem that we're trying to solve? Then working back to the solution. And when you actually look at some old aircraft, the Breguet 941, the YC-14 and 15, the QSRA, there actually was a lot of work in the 50s through 70s to try to pioneer these blown lift aerodynamics, really short takeoff and landing airplanes at large scale. The Breguet 941 was over 50,000 pound airplane. I mean, it was 50-seat class, intended to have a 400 or 500 foot ground roll. It was probably too big, and it was really ahead of its time. But the real challenge fundamentally is propulsion. That airplane had to have 4 turboshaft engines on the wing to enable even kind of mediocre blown lift aerodynamics. And it was not very failure tolerant. If you lost one of those turbines, you had a substantial performance degradation. They had to be cross-shafted to each other, so the mechanical complexity was really significant. If you look at the NASA QSRA, that airplane had integral ducted blowing. So inside the wing, there were channels that were actually blowing the wing internally. Those things are really complex at the end of the day. And so when you say, how can you solve this more simply? Honestly, electric motors make a lot of sense. I mean, we chose electrification for this airplane because it actually solves the problem in a very clean way. And that's ultimately because you can get a really high power, small package in an electric motor. You can put it wherever you want on the airplane, and you can distribute power from the energy source, in this case, fuel and a turbine running a generator, to where that power needs to be. In this case, 8 electric motors along the wing. And so by blowing the wing, we get much more lift think a normal airplane on takeoff and landing is like 2 to 3 for a max lift coefficient. Our product airplane, I mean, we're talking the wind tunnel test that we just did, we're talking almost 20. And so even if you back that performance off quite a bit, if you can get 3 or 5 times the lift out of the same sized wing, that really changes the game. That lets you fly very slowly under control during takeoff and landing, 30, 35 knots. And because you're flying very slowly under control, that lets you have a very short ground roll. And that's really it. This is not like being shot off of an aircraft carrier with a steam catapult and a tail hook. We're talking about going from 0 to 35 miles an hour. I mean, that's not something that most people are really worried about. You do it every day in your car going to a traffic light or a stop sign. And to think about doing that in a couple hundred feet is pretty inconsequential. It's really not a scary experience. And so that's really how the technologies work together, right? The blown lift aerodynamics enable slow flight under control. The slow flight with car-like accelerations gets you really short ground rolls. And then the hybridization allows us to power those electric motors with a long-range fuel source, with basically Jet A, sustainable aviation fuels, and frankly, whatever else comes next. We don't really care where the energy comes from. We just know that with 2025 and even into the early 2030s and beyond, battery energy density is just not going to be good enough and won't be for a few decades.
Right. So you've got, a lot of very smart people working on this who understand the history and the challenges with blown lift. You've made these design changes to accommodate it. Like you said, you are getting all of this extra lift from the wing, which allows you to reduce the speed of takeoff, which therefore shortens the runway requirement. And you've proven that this technology works already in test flights. And I think now that you're starting to really look at the applications for it. Recently in August, you had Mark Allen come over from Boeing to become the CEO of Electra. And around the time he joined, you started using this phrase, direct aviation. I think you actually used it a couple of minutes ago to describe kind of the operations that this thing will handle. What can you tell me about direct aviation? How would you define it? Because it sounds like a pretty intuitive term. And how is it different from some of the conventional operations that pilots and passengers are really familiar with?
Yeah, we sat down, and I was just say I've had the fortune of knowing Mark for the better part of 10 years, also at Aurora Flight Sciences and Boeing after Aurora was acquired. Really got to know Mark there and was very ecstatic that we were really able to get him to come join Electra. But, we took a step back and sat down and said, what are we really describing? At the time I described 5 years ago when we were thinking about the future market, we had this idea, these characteristics, but we didn't have a word for it. And so we really sat down and when Mark joined and put some vernacular to the concept that we had been describing. And I really, it's just super simple. I mean, it's going from directly where you are to where you want to go and doing so at a regional level. How does it really differ though? I think typically you see people talk about business aviation, general aviation, commercial aviation in the kind of traditional airplane world. And then on the future mobility side, you tend to hear advanced air mobility with urban air mobility and regional air mobility under that. And I think that's why we called it direct aviation, because none of those words, they don't really capture the spirit of what we're doing. They're kind of loaded in their own right. And so when you actually say, the capability that this airplane brings really requires you to think differently about an airplane. It's not general aviation. Yes, an individual could buy and operate the airplane as their own pilot. So sure, you could do that. It's not traditional business aviation in the sense that most companies probably aren't going to own a bunch of these. They're not going to have a fleet of them that are sitting in a hangar 90% of the time. These are meant to be run by commercial operators, principally Part 135 operators, at scale. And while that's also technically under the commercial aviation category, the idea of getting into new infrastructure and new spaces or repurposed infrastructure, parking lots. I'm sure you can all imagine a mall that's abandoned now and has a big parking lot right next to a populated area. But to be able to get into those new spaces isn't really in the spirit of what most people would consider commercial aviation or Part 135 ops. And frankly, in the future mobility space, regional air mobility, regional air mobility evokes more of the idea of like the Eclipse jet, right, where you have an airplane at scale that would fly airport to airport. Uh, and then certainly on the urban air mobility side, you're mostly thinking kind of eVTOLs and frankly helicopters as the conventional incumbent there. And so it just really doesn't fit into any of those categories on its own.
Yeah, it's interesting. I think we're really starting to see a shift towards, folks wanting this idea of direct aviation. We're already kind of seeing it a little bit with drone package delivery, for example. You've got companies like Zipline and Wing, that's the subsidiary of Alphabet, that are setting up these hubs in urban areas and enabling packages to be delivered. Now you're doing that, but for passenger transport. And I want to talk a little bit about the market for direct aviation, because in March, Electra reported about 2,200 EL9 pre-orders, and these aren't just U.S. fixed wing operators like you might think. You've got really a diverse range of customers around the world, and even some customers who are traditionally flying rotorcraft. What can you tell us about some of those customers and some of the use cases that they have in mind for the EL9?
I love the question because there's no limits to the creativity of operators to find new use cases. the to your point, 2,200 aircraft. There's 55 or so different operators right now. It's just incredible. About half of those are domestic in the U.S. Half of those are outside of the U.S. All of those are commercial. I'm sure we'll talk more on the defense side later. But the fact that there are 55 different operators that have put their hand up and said, this is a really game-changing capability. This is something that we're looking for in the future, I think says a lot to build the foundation that we're really looking at something that is game-changing, right? That will have a big impact. The different use cases are really interesting. I mean, I'll just say simply, a couple of them just want a better mousetrap, right? They just want an airplane that flies airport to airport. They are interested in being able to drive higher reliability, higher safety operations in a wider variety of weather conditions. But it's pretty simple, and they need to do so at a competitive price. But they're not really looking to unlock full direct aviation. There are those on the other end of the spectrum that are all in. They're developing new algorithms to match demand to aircraft availability, and they're trying to have effectively the Uber of the air, maybe even more scheduled per se than Uber, but somewhere between an Uber and a bus. And that's a really cool use case by itself. Some of the cargo operators, I mean, really high value cargo moving through Africa, as an example. There's some great use cases there. And then ultimately, where we think a lot of the real value comes from in the long run is moving people city to city. And so when you look at the number of city pairs, meaningful cities with a couple 100,000 plus people in the US, you could think of this as like Class Charlie sized airports, point to point. That by itself is really incredible. There's a huge network of untapped potential. And so we actually have had some really neat studies. We did a study with Georgia Tech where they actually looked at the Department of Transportation's National Household Travel Survey data. And so they just looked, where are people and where are they trying to go? And they had a really neat way of actually analyzing how they got there, right? So for cars, it was pretty easy. You drove point to point. But for airplanes, you can't. And so a lot of cases, people were backtracking. They're waiting a long time for a connection. Buffalo to New York is a good example of a city that's just poorly connected. The capital of New York City to the biggest city in New York. There aren't a lot of good options for that flight day to day. And so those are the kinds of really interesting future mobility routes that will start to open up. We talk about DC to New York. When we say DC, I mean, yeah, you could go from Dulles to LaGuardia, but alternatively, you could go from a parking garage in Tyson's Corner, which is much closer to where a lot of people actually live, or some other location, to the downtown Manhattan helipad or the new infrastructure that gets set up. So you walk right out of the airplane into the city instead of being an hour and a half away.
Yeah, I think DC to New York is a great example. I live in New York City, for example, and my options to get to DC, it's take an Amtrak, which takes about 3-4 hours, or drive to LaGuardia and fly, and then drive from DC airport to wherever I want to go. And you're really kind of filling in that sort of nebulous area in between, like you said, 50 to 500 miles.
That's
And I
I'm
think
glad that you can really resonate with that personal experience, because we live it a lot too, and you can just look at a map, just pull up a sectional of the map and draw your range rings there and see what cities do you want to go to that are otherwise really difficult to connect. The interesting thing that we're seeing on the direct aviation side is I think it's a very nonlinear kind of improvement where you talk about it being about a 4-hour trip, right? The reality of the real world being it usually starts at 4 hours, and then with delays and other irregularities, sometimes commercial aviation, trains, whatever, can be substantially longer than that. But frankly, it's a distance difference between a comfortable day trip and an overnight trip. And we can share one of the videos we put out at the product reveal, right, was this sort of tale of three travelers where one person gets up at 5 in the morning to leave DC. They rush out, they spend the night, and then come back the next day. Somebody, be it driving, be it flying commercial, all of those more or less result in the same situation. Alternatively, you could put your kids on the bus, make it in time for your meeting, have a whole day of meetings, leave at 5 o'clock, and make it home for dinner with your family too. I mean, it's very nonlinear. The difference between that night at home and that night away, especially to people who travel a lot or travel those routes a lot, is just fundamental and really game changing.
And I think key to all of this is that you've chosen a fixed wing design, which I think kind of shields you from some of the deficiencies that come with electric vertical takeoff and landing air taxis, for example. We cover those a lot at flying, and those are kind of really replacing operations that helicopters would perform. You've managed to gather interest from those helicopter operators while also being able to apply this for more regional trips, DC to New York, like you said, and other applications like that. And you've also gotten interest from the U.S. military. You mentioned defense earlier. I want to talk about that now. On the military side, what makes the design of the EL9 attractive to an operator like the Air Force, for example?
It's a really good question for maybe just to take a step back. And we're talking Air Force right now, but I'll just say we've worked with Air Force, Army, and Navy, have had contracts with all three, and they all have different flavors, some of which I can't get into all the details, but I'll just say, it's a very affordable platform that can do a lot. And so if you're trying to get into really small spaces, if you're trying to build a logistics backbone that allows the US to be competitive, to win in some really difficult contested environments, you need a low cost platform that can really carry a lot of weight. And so we have an interesting we actually had a gentleman named Don Yates join the team at the end of last year, and Don has a really unique background, having been an infantryman in the Army, an F-15 pilot, and at the end of his Air Force career was a colonel leading the largest squadron of F-15s in the U.S. And he's lived this distributed logistics problem. I mean, they were pioneering some of the agile combat employment, like concepts that people talk about a lot now. It's really tough. If you have a part, if you need a part, if you have a resupply issue, you're beholden to the handful of C-17s and C-130s. And it's really silly. I mean, one example, there was an F-35 that had needed a new helmet. I mean, the entire airplane was grounded until a helmet could be replaced. Not a huge deal normally, but if you don't have the control of those assets, if you don't have a way to call an airplane quickly and get that done, you're stuck. You have no other way to keep the fleet flying. And so there's some really interesting opportunities around, what you'd tend to think of as like C-17s being 18-wheelers, maybe C-130s as kind of the city delivery trucks, the bigger trucks. We're like the Amazon Sprinter van, the airplane that goes out and does a lot of the real distributed logistics that takes it from the airport out into the field or into these different agile bases.
So contracts with the Army, the Navy, the Air Force, the demand is clearly there on the defense side. And I think those contracts are so important because so often you see the military be kind of the first to really field some of these emerging aircraft designs. You're seeing it now, actually, even with other companies like Joby Aviation, Archer Aviation, Beta Technologies, who are also developing electric aircraft, very novel technology. And some of their first test flights have been with the military. So obviously a critical partnership. And another one that Electra has is with NASA. I want to dig into that one as well because Electra last year was picked by NASA for the Advanced Aircraft Concepts for Environmental Sustainability, AACES 2050 program. How would you describe that partnership and what exactly are NASA and Electra looking to get out of it?
Yeah, it's a great program. And we had the fortune at the end of last year, we took Administrator Bill Nelson flying in the EL2, the prototype two-seater that we have now. He put a challenge out to industry to see who could take him really flying in one of these aircraft, and we really answered the call on that. Uh, he's not a pilot, but he had a very long career as a senator, and in particular, was an astronaut at one point as well. And to have somebody like Bill Nelson come in, have the opportunity to fly the airplane, fly it himself, frankly, and also experience what it would be like for a passenger, I think was really, really powerful. His comments were in the videos actually were how smooth and quiet it was, and that's some of the elements that make it the EL9, or will make the EL9 a great airplane. Separately, NASA has long been working on what is the next generation airliner of the 2040s, 2050s look like. And so the ACES program is really about that future airliner. It's worth even just stating, sustainability is a big part of that particular program. But what we see a lot is a big part of being sustainable is not just the environmental sustainability, it's the financial sustainability. And you see very slow but methodical progress in the big airplane world. There's good reasons for that. This is a really neat opportunity to take some of the technologies that we're developing on the Part 23 sized airplanes and look at scaling them up to a Part 25 airplane to see where it helps with costs, to see where it helps with emissions and noise, and frankly, the big ticket items that are going to limit the scale that commercial aviation will be in the future. I mean, the market is growing for large commercial airplanes at rates that have not been seen in a long time, and that's going to be very difficult if we can't find ways to be more efficient with the resources we have and to be a better neighbor in the community. So specifically, what we're doing on that program is actually developing a concept for a future airliner. So this again is a 2040s, 2050s entry into service airplane. It's nominally intended to be 100 to 150 seat class. Again, pretty large aircraft. And we're there to really push the boundaries of what's possible with technology to show what could be done. There is certainly a very long-term interest in seeding some of those technologies and being able to develop aircraft at that scale. But we also have to be humble and pragmatic and say that's well beyond, building an aircraft at that scale is not the starting point for Electra, right? We have to climb the rungs of the ladder. We built the prototype two-seater. We are working on the nine-seater. We have to get that into service. We have to certify it. We have to make it an awesome airplane. Then we can start to scale up from there. And, while there's a lot of potential and a lot of opportunity, jumping straight to that Part 25 airplane is probably not the highest probability of success. And so this lets us work with NASA, work with the industry to climb the rungs in those ladders and show what the technologies can do.
I think something really critical that you mentioned, and I'm glad you brought this up, is the financial side of this. Because clearly this is, a very malleable aircraft with a pretty diverse range of applications. But when I interviewed Mark Allen back in March, he told me that all of those capabilities come with a lower cost and a higher level of safety than your conventional fixed wing aircraft or rotorcraft. On the cost side, just doing a little quick math, Electra reported pre-orders of about 2,200 aircraft, valued that at about 10 billion. The cost per aircraft there would come out to about 4.5 million, assuming that that's what's going into the valuation. Would you say that that's close to the intended list price for the EL9, or are there other factors kind of driving those cost savings?
Yeah, so a couple things to layer in. What do the operators actually track at the end of the day? CASM, cost per available seat mile. So, wrapped cost of the operation divided by the number of seats that could have flown. That's the metric of how cost efficient an airplane is. A part of that is certainly the purchase price. There's a lot more that goes into it ultimately. I mean, maintenance, fuel burn, the operating efficiency, the load factors that you see in an airplane. These are things that actually drive the net savings for the operator. But when we just talk about the actual sticker price of the airplane, I'd say there's a lot of nuance to these, right? I mean, what options get selected, what support and service packages an operator chooses, the bulk discounts for the larger buys, those are all major drivers. And so fundamentally, what I think we really focus on is designing an airplane, building the system, the company around minimizing CASM. And that allows our operators to ultimately have this, Part 25 technologies that are from Part 25 airplanes, fly-by-wire, this hybrid electric multi-engine safety, the access to incredibly small spaces, and do so at somewhere around half to a third of the CASM of a VTOL aircraft, and still be competitive with traditional single engine fixed wing. And if you can bring those things together, if you can have access to helicopters, competitive pricing with fixed wing single engine airplanes, and then multi engine Part 25 levels of safety all in one, that's game changing for all of those operations. It's pretty incredible to be able to do that, period, let alone to be able to do it competitively on price to the passenger, buying a ticket, as well as to the airline buying the airplane.
Right. So when you talk about cost savings, it's not just upfront cost. It's, operational savings. It's savings for passengers. And the other component there is the level of safety. Can you maybe run down some of the safety features that are built into the EL9? Because you're certifying this thing, correct me if I'm wrong, as a normal category aircraft with the FAA. How will the EL9, match or even potentially exceed the safety level of some of the other models that are operating in that category?
Yeah, when we started to really develop the requirements for the airplane, I like to just start by reminding everybody that the certification bar is the minimum threshold, right? I mean, you have to cross it, but it doesn't necessarily make for an excellent airplane in the long run or a very high reliability, high safety airplane. And so we as the company have to raise that bar above the certification threshold. What we actually did was go look at the statistics. I mean, we started with what are the Part 135, the accidents in Part 135 operations and Part 91, but 135 is mostly driving this kind of use case. And there's four really big ones: loss of control in flight, controlled flight into terrain, a power plant failure, an unintended flight into IMC, which typically results in some kind of spatial disorientation. That's 70% of the Part 135 accidents. I didn't, not Part 91 GA pilots, Part 135 professional crews in serious, commercial operations. I mean, 70% of the accidents being attributed to those four things. We can do so much with 2025 plus technology to address those causes. And if you just start with loss of control in flight, fly by wire. The decision to make the airplane fly by wire from the beginning was not one that we took lightly, but one which we think will make very nice flying qualities all the way from the 30 knots on final to 175 knots, even up to VNE, but also allow you to build in all the envelope protections to allow one to effectively eliminate the loss of control in flight accidents. Controlled flight into terrain, a lot of this comes down to the avionics. We're not ready to share some of the work that we're doing on the avionics today, but towards the end of the year, I think you'll see some really neat announcements and a lot of thoughtfulness that we've put into the design of the flight deck, the human factors that go along with a modern airplane, and in particular the systems management too. So power plant failure being one of the chief systems failures that you see as a cause of accident today. Well, there's 5 different energy sources. You've got the turbine, you've got 4 batteries, 8 electric motors on 4 independent buses. You can lose the turbine, you can lose batteries, you can lose a couple motors. That's really powerful, and it still gives you the ability to really control where you're going to land safely. And as a multi-engine pilot, many people are familiar with the drill. Mixture, prop, throttle, gear up, flaps up, identify, verify, feather. You don't have to do that. A motor failure, a turbine failure is a CAS message that says something like motor 1 fail, but you don't do anything different. The airplane has taken care of itself. It's controllable. It has performance, which still is guaranteed. So the takeoff and landing distances are guaranteed with the motor failures considered, with the turbine failures considered. It basically turns an emergency into an urgency, right? You don't want to sit around and fly like that for the rest of the day, but you can land safely and have all the time in the world to wind your watch, to troubleshoot, to think through it. And that even goes one step further when you see some of the thoughtfulness that we're putting into the systems management. There is no reason in 2025 that one has to do so much manual systems management. We have a lot of opportunity to allow that to be taken care of by the airplane in the background to handle the reconfigurations and failures and make it very transparent to the pilot. Pilot needs to understand it, no question, but they don't necessarily have to do all of the work themselves, and especially in these really high workload environments. And last part, unintended flight and IMC. The spatial disorientation that comes with that, again, addressed by fly-by-wire. And then also, if you really get disoriented, having an emergency auto land, the push button, both in the event of pilot incapacitation or disorientation, to get the airplane back on the ground safely, is a really powerful feature, even in these Part 135 operations.
And I think that's really important because if you're, a pilot, just familiarizing yourself with a novel design like the EL9, I think the last thing you want to be thinking about is, what am I going to do if something goes wrong? Obviously, it's something that's going to cross your mind no matter what. But to be able to, be assured that there's redundancy in place, that there are systems designed to combat the 4 key types of accidents that you mentioned, I think would be reassuring. Switching gears a little bit here to kind of close out the discussion. Electra announced a funding raise on Monday, April 21st. That's the day that we are recording this. $115 million Series B round, led by Prison Capital, that is going to support pre-production and certification. I want to ask you, what are Electra's, testing goals for 2025? What would you like to have completed by the end of the year?
Yeah, it'll just say it's a great vote of confidence. In a time where the markets are very challenging, to raise that kind of money now and really launch the EL9 development after the product reveal we did at the end of last year is just phenomenal. And the team at Prism is a group of phenomenal partners and advisors too. Specifically to the goals for 25 on the testing side, I'll say that there are some really, really neat demos that we're pulling together with the EL2. I don't want to give away too much yet, but just say really stay tuned. This year, we're going to be doing some incredible things with the airplane, putting it in places where you don't normally think of airplanes going, both for some of the commercial demos as well as the government. And as a part of that, we're actually really working even steeper on the backside. We did an upgrade program with the EL2 over the winter. So we've actually now got 70 degrees of flaps, big double slotted Fowler flaps with 70 degrees of deflection. We can fly even steeper approaches. We can fly even slower. And so we're going to find the real edges of the EL2 envelope. We actually have done a very successful tunnel test program for the EL9 already. There's some other work that we're going to do on the wind tunnel side to help build out the air database for the EL9. But honestly, a lot of it at this point is we got to turn the crank and do the work to start doing the detailed design of the airplane. And so that is the big focus and delivery for 25 and to an extent even into 26 is getting that hard real core engineering work done to design the airplane at the end of the day at the low detail, at the high detail.
So big plans for that EL2. Just for our listeners, the EL2, nicknamed the Goldfinch, that is the two-seat demonstrator kind of prototype of the larger EL9. And beyond the testing, what would you say the road to certification looks like? And at this point, how confident would Electra say it is in delivering the EL9 to customers in 2029?
It's fun to ask the question, because when you were talking about the idea of package delivery with UAVs, with drones, I just go back to 2013. That was one of the first things that we were working on in the UAV world at the time. It was relatively new, agriculture disease detection, the idea of delivering packages, and here we are 12-ish years later, and it's almost kind of real in some places. They're real use cases. I'll just say what really makes a good product and a successful company that's ready to launch. It has to have a business model that closes. I think we've talked a bunch about the cost competitiveness of the airplane, the chasm for the operators, the value proposition for the new direct aviation market. So got the business model check. It needs a fundamental technology that works. That's not true for all concepts, and so we have a very very strong technical team, both of the traditional aviation minds. Buddy Sessoms, former chief product officer at Piper, chief engineer for the M series, now leading the certification test validation at Electra. Randy Griffith, the head of certification for the Honda Jet, for the Eclipse Jet, Mooney M10, also leading the certification programs, the certification at Electra. Great minds that really know what they're doing. And I think the big difference is we have the regulation on our side. I mean, at the end of the day, the problem 12, 13 years ago is that the regulation to operate, let alone certify the unmanned aircraft at the time, didn't exist. And so it was really having to clean sheet develop the whole back end regulation and infrastructure from scratch. And I think you'll see that's a big part of why ultimately the ultra short takeoff and landing airplane, the direct aviation market, is such a good fit, that it is well established. It's just an airplane. It's a multi-engine, fixed wing airplane, level 3, low speed, no magic there. There are some new technologies in this particular size airplane, but the turbo generator is nothing more than an APU. Every Part 25 airplane for decades has had an APU. There is a lot of precedent that exists. Safran has now certified an electric motor for general aviation aircraft. I mean, these technologies are really a lot more mature, and because we don't have to redo all of the regulation around the aircraft cert, around the pilots, around the operations, because we can be just an airplane, that goes a long ways to fundamentally simplifying the certification program and the rollout. And I think you see these challenges really emerging now in the eVTOL world, as they have to reinvent the certification regulations, they have to reinvent the operating regulations, and even things as simple as pilots. I mean, in most eVTOLs are powered lift category. It's traditionally only reserved for the handful of V-22 pilots coming out of the military with the equivalency. Now all of the pilots of those aircraft have to become powered lift certified pilots. Whole new category. That's a high bar. And so for us to be able to fundamentally simplify our approach is really powerful, and ultimately what leads to the confidence in our ability to certify.
Right. So you've got the business model, you've got the technology that has been validated already through testing. You do not need to worry about new infrastructure like vertiports or new regulations, like you mentioned, some of the eVTOL companies are contending with right now. The FAA, had a big change a couple of years ago, introducing this powered lift category, which really threw a wrench into all of those certification plans. And a lot of these eVTOL companies have pushed their timelines back. That's something that Electra doesn't have to deal with. And before we wrap up, I think I would be remiss not to ask you about the current tariff environment. You mentioned Safran, for example, which is supplying the turbo generator for the EL9. Do you foresee any impact from tariffs on, manufacturing or sales down the line?
I'll just say it's a really dynamic environment at the moment. So the what is the current state of regulation changes relatively frequently. And so I think a lot of people are still feeling out and kind of waiting for a little bit of stability there. I'll just say that all of our partner companies, I mean, have substantial U.S. presences, and so Safran, for example, does a substantial amount of overhaul and actually the manufacturing of some of their core turbines in the U.S. in Dallas area. Honeywell is providing the flight control system and the fly-by-wire, both the fly-by-wire control system as well as the actuation. Honeywell, one of the best known American aerospace tier ones out there. There's a lot of experience in working through the supply chain. I think as things get stability, start to become more stable, we'll start to see that shift more deliberately, and new supply chains and ways of building will get set up. But it's really hard to say right now. From our perspective, and what we're discussing with customers, not huge impacts at this stage, but as I said, it's hard to know right now.
Definitely. So I think fair to say, not a big concern for you at the moment.
Not at the moment.
For sure. We'll have to keep an eye on how it develops. But before we wrap up, is there anything else that you think listeners need to know about the EL9?
I think we've covered a lot. I'll just say for some of the milestones, hopefully we can get you out sometime to come fly it and see what the experience is like for yourself.
I think readers would definitely appreciate that. And for listeners who want to stay in the loop on EL9 updates, what's the best place for them to go?
Electra.Aero is the website. Literally Electra.Aero. There's a newsletter on there that you can sign up for as well, and you'll get some of the news flashes directly. And of course, Flying Magazine.
Appreciate the plug, JP. It's an exciting time for aviation right now. We've got a lot of new aircraft concepts like Electra's EL9 coming out, and I think it's one of the more interesting ones. So thanks for joining us, JP, and stay tuned for more the best of what's new.